Hello guys, good evening. Good evening. How are you guys? Good? All set for the session? Cool. Okay, so we'll just start a session, and before that, what we'll do our regular audio and video check. Just give me a moment. Just check it. So meanwhile, if you are having any sort of doubt regarding our definite integration sessions, you can ask me. Varun, good evening, good evening, good evening. How are you, buddy? So all set to learn definite integration. Tell me, Varun, you are in 11th standard. So you are learning your integration right now. That to definite, not even indefinite first. Okay. So it's already a minute. So it's 8 past 2 p.m. So directly want to learn definite integration. Okay, fine. So let's start our session now. And hello everyone, good evening. I welcome you all on Let's Crack JEE in English channel, and this is our marathon session for JEE 2021, and this is for definite integration. And that's me, your teacher, IIT Bombay graduate and postgraduate Nishant Khanduja. My rank in IIT-JEE was 1256, in IIEEE it was 363, in Rajasthan pre-engineering test this rank was 4. I have traded in US and Canadian markets for 2 years. I also have 8 years of teaching experience, and the reason why I became the teacher, it's something, what should I say? It's all because of I always wanted to teach students, those who are there in small cities, small towns, because I was also one of them, and above all I didn't go to any coaching institute when I was preparing for this competitive examination. So I always have this thing in mind. What about those students, those who can't go to coaching institute and they still want to prepare for this sort of competitive examination? Given the fact they have good raw potential, it just they don't have the proper guidance or good infrastructure, and that's why they couldn't clear the examination. So I thought, why not I share my experience with them? So when I just, as people say, when there is a will, there is a way, right? So I met Unacademy people, and Unacademy made me meet you guys, and I became, or I associated with Unacademy for their largest campaign, India's largest campaign, that is Crack IIT-JEE. And here I'm doing my small bit by teaching you guys mathematics for IIT-JEE. Now, if you want to learn from me, so how can we get associated? There should be a medium, there should be a platform. That platform is your Unacademy learning application. When you go to that application, there are ways to study from all the top educators available on Unacademy. Obviously, I'll also be there. So the very first benefit you will get if you go for plus subscription, you'll get to attend daily live classes. So these daily live classes are not YouTube live classes at all. These daily live classes are going to be conducted on the Unacademy platform, and the kind of experience you're going to have, that is remarkable. You can't even compare it to your YouTube live classes. The kind of engagement, the kind of discussion you're going to have there with the educators, that is brilliant. You can ask doubts, you can even just be a part of polling system also. So overall, I can say that you would get offline classroom experience. You can also attempt live tests and quizzes, and you can evaluate your preparation. You can also attend the structured courses conducted by all these top educators. What I mean to say is, let's say if you come to know that there is a really good teacher, and he teaches physics, and he is there in Hyderabad, and you are there in North India. You can't go to Hyderabad, obviously. But don't worry, that educator is there on an Unacademy platform with his structured course. So what you will get, when you attend structured course, you will get maximum knowledge in minimum time. So it's like, and you be at your place. So these are the good benefits you get when you go for plus subscription. And there is one more benefit, which is, I consider that a boon of technology. Why? Because you can attend or you can access all the recorded videos by these top educators. So how it is a boon? Because I have felt many students saying that whenever a teacher teaches us, then only we can understand. Otherwise, revising or studying from books, it's very difficult. But don't worry. Whenever you feel like you want to revise something, just go and watch these recorded videos. No matter what is the time, when you want to watch it, where you want to watch it, n number of times you can watch these videos and revise your topics. And this is the benefit of Plus subscription. When you talk about your iconic subscription, so whatever benefits I just spoke about for your Plus subscription, apart from them, you will be getting a personal mentor. So this personal mentor will be working with you for the next 1 hour or 1 year or maybe 2 years, depending upon the subscription package you choose. You also have test analysis report. So that test analysis report would tell you to improve time management. It would also guide you to approach your examination. It would also tell you where exactly, in which section, in which topic you are losing marks, how to reduce your negative marking, how to get better marks. You also have study planner. That study planner would plan your study, or I can say it would customize your study plan depending upon your own needs. It would also review your progress bi-weekly. If at all it feels, let's say there are any changes, then those changes will be incorporated in your next study plan. So if you just see, this package is what, apart from content, it also works upon your result, right? It works upon your result. So I can clearly say this is what, this is goal oriented subscription. Would make sure that you would deliver or you would give the best result possible. Clear? Now, if you want to buy the subscription, then what to do? Go to Unacademy Learning App, the very first thing. And second, when you go for Plus subscription, there are options available, let's say for 1, 6, 12, 24 months. Then which subscription to buy? This might be a question. Then I would help you out. If at all you are in 11th standard, then go for 2-year subscription. If you are in 12th or you are a dropper, then go for this 1-year subscription. Reasons are very simple. See, let's take a student who is there in 11th class. Now, for him, the preparation is for 2 years. So he would love to access the application for his mock test, revision, till the examination gets over. Now just imagine if just before the examination your subscription gets over, you won't be able to attempt mock test and revise things. Eventually you will not feel confident when you are going for the examination. So that's not a good stage, right? So it's better you should have the subscription for the entire 2 years. Second one is, since it's a 2 years preparation, so all the educators, they have designed the courses in such a manner that every single topic will be covered in that time span, keeping enough time for every single topic. No. Now, if your subscription gets over in between, you would end up skipping a few topics. Again, you would not feel confident when you are going for the examination, and again, that should not happen. Third one is, it's very cost effective. Look at the price, 2,333 rupees per month. If you just look at per day wise, what it is 78 rupees per day. And if you look at per day per subject wise, 26 rupees per day per subject. And this is what you are going to pay for an educator for this, for 1 day, for the entire subject. 26 rupees per day. That's a very nominal amount, right? So if you accumulate everything, the amount you need to pay for 2 years is 56,000 rupees. And for 1 year, you need to pay 38,500 rupees. But if you apply my code NK001, things would change and you would get what? 10% discount, and the prices would become, for 2 years it would be 50,400. For 1 year it would be 34,650 rupees. For iconic, 2-year subscription would cost you what? 86,000. For 1 year it would cost you 56,000. Apply my code NK001 and see the magic, and you would get 10% discount, and the prices would drop down, and the price would become, for 1 year is 50,400 rupees. For 2 years it would be 77,400 rupees. Now that's all. Now you can buy the subscription whenever you feel like. Now the question is, if you ask me, sir, when should I buy this subscription? The answer would be, better you buy it ASAP. Why? Because the earlier you buy, the more time you get for your preparation, better result you will deliver. Right? It's a very simple funda. The more time you have for your preparation, the better result you will give. It's a very simple statement. Okay. So everyone is up for your definite integrations marathon session. Okay, so we'll start. So Varun says, have you cleared PRMO? Nobody. I didn't clear that. Actually, I'll be very honest with you. So since I belong to a very small city that is there in Rajasthan, Bharatpur. So in Bharatpur, people are not aware about Olympiads and all. They are only aware about big competitive examinations like IIT, NEET. That's it. Or maybe civil services like UPSC. That's it. So these are the exams they know. They don't know about Olympiads and all. So that's why I couldn't appear for this examination. Had I known about Olympiad, I would have prepared for this examination for sure. Okay, so let's start. Definite integration. Now, what is this definite integration? See, we have spoken about indefinite integration, what it is definite. So this definite integration tells you, or it gives you the value between an interval. Now, to make you guys understand what it means is, Varun, no, I am doing first theory, and between in theory I'll be doing questions. Then later on we have multiple questions. So it's like there are almost 4-5 slides for the theory. Then post theory there are let's say 6-7 questions. Then again some other theory part. Then again questions. Okay. So I would suggest you better if you are there, you better understand this topic and it will help you a lot. Hi Ishan. Yes, okay. So what is the definite integration? So basically it gives you the area under the curve. This is the geometrical interpretation. Area under the curve. Now, how can we make it definite? So definite is basically when I put the limit. Because see, if I am calculating the area can start from this value to this value, and that can't be counted, right? If I apply a limit, lower limit and upper limit, then it becomes what? Definite. It becomes countable. Are you getting it? So now this is, and that's how we represent this. We represent this definite integration by like this. And it is representing what? Area under the curve. And as we know, when we have set the limit, so obviously that area will be definite. It will be counted, right? Hi Ishan buddy, how are you? So this is a definite integration, and that's how we represent it. Now let's move ahead and let's talk about its first principle. So what I mean to say is, let's say if there was a scientist and he wanted to calculate the area under the curve, then how did he approach this question? Just think about it. So let's try to do it. And this principle is called your first principle. I'll tell you what he has done it. So let's say he wants to calculate the area under this curve, and this curve is, let's say, f of x, and this is your y-axis and this is your x. Fine. And this is your a and this is your b. So he wanted to calculate this area. So now what he has done is, since obviously let's say there were no options available for integration and all, and I'll tell you one thing, whenever we do coding and all also, so in coding also, if you are making, let's say, any software and all, you don't put formulas, because obviously there are different functions and you can't integrate them because there is no standard formula, right, for the integration and all. For different functions there are different techniques to get the answer, but then there should be some method by which they they get the best possible answer. How do they get it? So this is the first principle, and that's how people code also. So what he did is, he thought, let's do one thing, let's make infinite, or you can say n number of stripes between B and A. Between B and A, this is the width of this line B minus A. So what he thought is, let's divide this B minus A into n parts, and when you divide this B minus A into n parts, you got these n stripes. And what is the thickness of every stripe? It's very easy. The thickness divided by total number of stripes will give you what? Thickness. And this thickness is being denoted by h, and h is what? H is this, B minus A by n. Clear? Now tell me one thing. If I want to calculate the area, how can I calculate the area? I'll use a different color so that you'll understand, and I'll make different stripes like this. Now what he has done is, he has calculated the area of every single, so every stripe is like what? It's like a rectangle, right? So what he has done is, he has calculated the area of these rectangles. So now tell me, how many? So let's say if I take rectangles starting from this, starting from the very first. So if I zoom it, how would you see it? You would see it like this. This is your A point, and at A, what is the value of the function? F of A. At A plus S, what is the value of function? Your F of A plus H. Okay. Now what he has done is, he said, let's do one thing, let's calculate the area considering this F of A side. So the other side is also, he considered that is also equal to F of A only. So the area for this stripe, the very first stripe would be what? Area for first strip would be what? The thickness, your H into F of A, correct? Right? Now this is the area for the first strip. Now how many strips are there? Your n. Starting from here, you will go till here, last one. And what will be the value of the function here? This will be F of A plus n minus 1 H. Yes or no? Yes, obviously. Because this, your F of B is what? As you can see from the formula also, B is what? B is NH plus A. So if you are getting F of A plus NH, that will be what? Your value of F of B. Correct? So for the last stripe, area, what? H into F of A plus n minus 1 H. Now what you can do is, similarly you can calculate the area of every single strip, and you can add. So area under the curve, it is what? It is H into F of A plus F of A plus H, and this will continue till F of A plus n minus 1 H. Right? So this is your area under the curve. Now this is one way. That's how you approximate it in one way. Now what could be the second way? So right now I assume that this would be the triangle where the side is what? F of A. Now if I want to calculate the area of the first strip the other way around, what I mean to say is, when I consider the length will be equal to what? F of A plus H. I can assume the area like this also. So what I mean to say is, if this is my curve, this is F of A and this is F of A plus H. So at once, initially we calculated this area. In the other case also I can calculate this area. And what I'll do is, I'll keep shrinking my H. When I keep shrinking my H, what will happen? These both these rectangulars area will be approximated to the area under the curve, right? So we'll do that. Just hang on. So area under the curve in first case, second case क्या होता है? Second possibility. Second possibility for the area. H into, for the first stripe, it will be A plus H. And we'll keep continuing. For the last stripe, it will be what? F of A plus NH. Like this. Okay. Now, if I write it in summation form, so how will I write it? H summation starting from F of A plus RH, and R will be what? Starting from 0 to n minus 1. See, both are having exactly n terms. It is just the difference of the first term, and it is starting from 1 to n, and this is what? F of A plus n RH. Okay. Now as I said, see, these are the both areas. So obviously this one is slightly higher. This one is slightly lower than the area under the curve. Cool. Now just imagine. Now imagine if I shrink H. Shrink H means the thickness of the stripe. If I make it, or you can say if this H tends towards 0, what will happen? If this H tends towards 0, what will happen? We'll get the best possible approximation for the area under the curve, right? So that would be what? Limit H tends to 0 will be H tends to 0, H into F of, starting from summation R 0 to n minus 1, F of A plus R H, or limit H tends to 0, H into summation R starting from 1 to n, F of A plus R H. And this will be equal to what? This will be area under the curve. Okay. So this is called first principle, and using this first principle you can calculate your definite integration easily. And this will be equal to what? This will be equal to your integration starting from A to B f of x dx. Okay guys, hope you guys have understood your first principle and the formulation for the first principle. If you have understood it, just give me a thumbs up. Come on guys, give me a thumbs up. This is your first principles formulation. Ishan, Varun, give me a thumbs up. Okay, let's move ahead. Let's talk about the second theorem. Okay, now what is the second theorem? What second theorem says is you want to calculate the definite integration, right? So what it says is, let's say when you integrate it, so the antiderivative of this function f of x is, if let's say that is f of x, and the function is also continuous, your f of x is continuous, and the antiderivative of small f of x is what? Capital F of x. Then in that case your definite integration will be what? F of b minus f of a. This is your second theorem. Second theorem says use your antiderivative. When you use your antiderivative, and how do we get that? You can use your simple methods. What are those simple methods? Your indefinite integrations method. You calculate the antiderivative. Once you calculate the antiderivative, just punch the values of your upper and lower limits in that function and subtract them. Okay, but you have to remember one thing. It clearly says that your f of x should be continuous. Similarly, when your f of x is continuous, obviously there are good chances, but you better also check your continuity of your antiderivative also in that interval a to b. Okay, So is it clear with guys? Is it clear with everyone? Varun and Nishan and whosoever is present in the class? Okay. So this is our second theorem. Now we can interchange. We can interchange our second theorem and your first principle. Okay. Let me tell you one thing. Your first principle, we call your first principle as the first principle method. This is called limits of sum. We call it what? Limits of sum. Remember this because you might see this sort of thing in the questions also. One more information I would like to share this with you guys, that your definite integration can be calculated very easily using your limits of sum that we have seen using your first principle, right? But I would like to share one more information with you the other way around, that sometimes when you are calculating the summation, when you are calculating the limits for the summations, you can transform them into definite integration and you can solve them easily using your second theorem. What I mean to say is, I'll make you understand. What I'm saying is, let's say you have been given some sort of summation and limit of summation is given to you. Okay, you can convert this into what? Definite integration. Because this is, see, integrating something is easier, right? Except adding adding infinity terms. Integration is still easier. So you can convert this into what? Definite integration, and you can solve it. Don't worry, I'll tell you how you guys can do it. The way to do it is, when you get this sort of limits of sum like this, 1 upon something. Wait, what I'll do is I'll start from the basic principle so that that will be easier for you. So what I mean to say is, your definite integration is being represented by like this, correct? And you know that is what? That is your f of b minus f of a, correct? But using your first principle, what it says h, or your limit h tending to what? 0, h summation starting from, let's say, r 1 to n, and this is f of a plus r a. Okay, now what I'm doing is I'm transforming this into n. How? Because I know if my upper limit is b, lower limit is a, then h is what? H is b minus a by n, correct? So this will be equal to what? This will be equal to limit. If h is tending towards 0, that means n, your n will be tending towards infinity, correct? So this will be what? B minus a by n, and summation starting from 1 to n, f of a plus r by n, and into what? B minus a. I hope you guys can read it. A plus r by n into b minus a, correct? Now just assume, or you can assume a case where b is what? Equal to 1, a is equal to 0. What I mean to say is, your lower limit is what? 0 and upper limit is 1. So in that case, your limit becomes what? N tends to infinity, 1 upon n, summation starting from r to 1, f of a plus r by n. This becomes your final limit, right? Now, if you get this sort of term, you can transform this into integration, definite integration. How? I'll tell you. Write r by n as x and 1 by n as your d of x. Okay, so and your limit summation will become what? The limit summation will become as your definite integration sign with the limits, lower and upper. So 0 to 1 will become f of a plus, so a is already, we assume, 0, 0 plus x. So basically, can I write f of x only? F of x into d of x like this. Now this becomes the integration, or definite integration. So if you get that sort of limits of sum, what sort of? I'll write it clearly. Limits n tends to infinity 1 by n summation starting from 1 to n f of r by n, or like this, f of r by n. You can convert this into what? Definite integration like this. Okay, I hope you guys have understood this. If you have understood this, just give me a thumbs up. Give me a thumbs up, guys. Ishan, Varun. Okay, let's move ahead. Let's talk about the observations. The observations are, and these are the observations which are specifically there in your second theorem. What second theorem is? Because as we just spoke about, that your definite integration can be represented as value of the antiderivative at b minus value of the antiderivative at a, right? Now, it might be possible that at the upper and lower limit, your function is not defined, but it is defined in the entire open interval. What I mean to say is, if you have this sort of function and this is your interval a to b, it might happen that your function will not be defined here at the upper and lower limit, but it is defined in the entire interval, open interval a to b. Then in that case also, you will get the same definite integration answer. Same thing. Okay. Let's talk about the second observation. Second observation is, if your integration is turning out to be 0, if definite integration is turning out to be 0, then your function will certainly pass from the x-axis, or you can say it will have at least one root for sure. Now you'll say how? I'll tell you how. See, when you are calculating the area under the curve, just imagine. So obviously you will get positive quantity, right? It's basically the area below the curve. It's area below the curve and above the x-axis. Okay. Now just imagine, if it is always above the x-axis, you will get positive area. Correct? But how can you get negative, or how can you get zero area? There are only two possibilities. One possibility is either this function is along the x-axis. You can say that means y is equal to 0, or this curve is going into negative y direction also. Then in that case, the part where the function is above the x-axis, then the area below the curve will be what? That will be calculated positive. Here what is happening? Your y has become negative. Y is your basically negative. When y is negative and this your x is still positive, the area will be what? Overall area, negative number into positive number, your area will become negative. In that case, your negative and positive might give you what? 0. So that's why I said, it will certainly have at least one root in that interval a to b. Okay, hope you guys have understood it. Let's move to our next observation. Okay, if function should, your function, the function which has been integrated, the function needs to be defined in that interval a to b, else integration will have some error, that will not have the correct value. What I mean to say is, if you are planning to, let's say, integrate your 10x is starting from here to here, and this is your pi by 2, and this is your till minus pi by 2. And if you are integrating, let's say, 10x from 0 to pi, certainly you will have problem. Why? Because your 10x is not defined at pi by 2. If you are integrating your 10x from 0 to pi, it will certainly have problem. You will not get the correct answer. So always make sure that your function is continuous and well defined in that interval. Okay, and also check the continuity of your antiderivative also. Also check the continuity of your antiderivative also in the same interval a to b, and your functions continuity also, which is being substituted. Sometimes what happens, your overall function is perfect. Overall function is perfect, that is defined in the entire interval. But the moment we substitute it, with, let's say, some sort of trigonometric functions, then it creates some problem. I'll tell you why. The reason is very simple. What happens when you substitute, let's say, x is equal to, let's say, 10t. So what you are actually doing is you are playing with 10, your trigonometric properties, and you know that trigonometry has some sort of constraints. When we talk about inverse trigonometric functions and all, and we talk about trigonometry also, they are not defined at certain values, correct? See, if you see any algebraic function where x is there, obviously this function will be defined everywhere. But the moment you put 10t, now it might happen, let's say you are getting some value of x where this function is not defined, and the entire question will go wrong. So always make sure when you are substituting it, check the function which has been substituted. Is it continuous? Is it continuous in the interval, the limit interval that is given to you? Just check that also. Okay, guys. So these are the very important observations, and I would say just focus on these two observations a lot, because sometimes what happens, we don't realize and we solve the question and we stick to the answer, whereas there is a flaw in the question. Okay, so in that case what we need to do is we need to break our limits. When we break our limits, the question becomes easier to be solved. Okay, guys, I hope this information is beneficial for you guys. Okay, let's move ahead now. Okay, so this is the quick revision for you guys. You can just mug up, or you can just recall all the indefinite integrations formula. Why I am sharing these formulas with you? Because the second theorem clearly says if you know the antiderivative of the function, you can easily calculate what your definite integration. So these are the antiderivatives for these standard functions, and these are also there. Okay, guys. Okay, let's move ahead. And here comes our very first question of the evening. Varun, are you there? Varun and Nishant Haldar, are you guys there? I guess all of them are absent right now. They're not there. So okay, so people, those who are going to watch this video later on, for them, they can start solving the question. So what is our first? So it says limit of sum. That means first principle. It is asking us to solve using our first principle. So what was that? That says h limit, or h tends to 0 summation starting from, let's say, r1 to n f of a plus r h. Here, let's, and here h is what? I'll just put h is b minus a by n. Okay, now let's do one thing. Directly put the values here. So it's what? Limit h tends to 0 and h multiplied with f of a plus what? A plus h. Now this a plus h is what? Now this a plus h is basically, if you see, this is x raised to what? X raised to what? This is x raised to cube. So what you are going to do is you will be putting a plus h in x. So it will become what? A plus h whole cube. Similarly, what? A plus twice of h cube, and this will keep continuing till what? A plus nh. Right, guys? Okay. Now let's do one thing. What I'll do is I'll just play smart here, since it's a what? Cubic expansion. So let's open. So how many terms of a I'll get? Because when I'll open it, I'll get a cube from here, a cube from here, a cube from here. here n terms, so n a cube. Sorted. Similarly, n times h cube. Correct. Similarly, n times, I'll get what? Okay, not n times, just hang on. Not n times h cube also. Only n times a cube. Let me just rub it, guys. Why I said not n times, I'll tell you the reason. The reason is very simple. See here. I'll have h cube from here, twice of h cube. So basically h cube will be common, but I'll have what? I'll have 1 cube, I'll have 2 cube, I'll have 3 cube, and it will keep continue till what? N cube, correct? Plus here what will I get? Thrice of what? Thrice of a square, right? So a square is this, so I can take thrice of a square common. Now what is left? I will be left with h plus 2h plus 3h. So basically I can say, if you want, I can pull out h from here. I'll have what? I'll have only 1 plus 2 plus 3 plus 4 and like this till n comes, correct? Plus, and from this also, the last term from the expansion, from cubic expansion is what? 3a, a will be as it is, correct? 3a h square. When you do h square, you'll have h from here, h square. But for this, what will you have? For this, you'll have 1 square, 2 square, 3 square, like this till n square. So this is the final term you'll get, right? So basically 4 terms. Every term is having what? N terms. Fine. Let's move ahead. Limit h tends to 0. Now if you multiply this n inside, what do you see? It becomes nh. And nh is what? B minus a. Let's put it here. B minus a cube, plus this is h cube, and this becomes what? H into h raised to 4. What we can do is, we can play one thing. This becomes n raised to 4 times, and this is what? N into n plus 1. This is square by 4. This is the summation for the cubic, your summation of cubic natural numbers, right? Plus this is thrice, and this is thrice, and a square is common, and h, and what it is? H square from the outside, and it has n into n plus 1 by 2, right? Plus thrice of a and h cube, n into n plus 1, 2n plus 1 by 6. Clear? Now what I can do is, I can directly, so since I have already put this value, it's okay, h tends to 0, b minus a cube. Now what I can do is, I can take n square common from here. When I take n square common, so what do I get? I get n raised to 4 into h raised to 4. Directly I can write it as b minus a raised to 4, and this becomes what? This becomes 1 plus 1 by n square by 4. Here this becomes what? 3a square by 2. Again I can take n common from this, so it becomes what? N square h square. I can write it as b minus a whole square, and what it is now, the leftover is your 1 plus 1 by n. Here, plus this becomes what? 1 by 2, because 3 by 6 is there, so 1 by 2. A common, I can take n common from the numerator. When I take n cube common from the numerator, n cube into h cube, what it becomes? It becomes what? B minus a cube, correct? And what is left for me? 1 plus 1 by n and 1 plus, so 2 plus 1 by n. That's it. So this is what I get. Clear? Any doubt? No? Okay, let's do it. Now we can put the limit. H tends to 0. So when I put the limit, so what do I get? B minus a a cube plus b minus a raised to 4. This becomes 0, 1, so only 4, plus 3a square by 2 b minus a square. This becomes again 1 plus 1 by 2 a b minus a cube into 2. So 2, when it comes 2, it becomes only, that's it. So let's solve this now. When you try to solve this, what I can do is I can take b minus a common from everything. So I got what, a cube from here, b minus a cube by 4 plus this becomes what, a 3a square by 2. I can let's do shall I multiply? Okay, let's multiply because or let's try to simplify it. Let's see how can we simplify it. 3a square by 2 b minus a plus a into b minus a cube. What I'll do is now I can take, let's say, b minus a common from these three terms. These three terms are available, right? So let's simplify them. B minus a is left over for you, and now it can become a cube as it is. If I take b minus a common again, what do I get? I get b minus a square by 4 plus 3a square by 2 and plus ab. Okay, what I can do is, okay, a b minus a square, this is cube, and again this is also cube. 4 times, wait a minute, I guess we made, yes, this is, see, b minus a cube will become what, square, when I took one common. Now this time when I have taken one more common, so it will become only one term. That's it, like this. Okay, now what we can do is we can just solve these two terms. What I'll do is I'll just solve these two terms here so that we save our time. So b minus a common if I take, so I have b minus a by 4 plus a. So if I take the LCM, so it becomes 4 here, 4a, and I have got now b minus 3 of a by 4. Okay, and this is b minus a multiply. Okay, b minus a into b minus 3a by 4. Now let's do one thing. Let's add this to 3a square by 2. Okay, so for that what I'll do is I'll multiply first, then keeping 4 in the denominator. So when I multiply, so what do I get? b square minus 3ab minus ab, then we have a plus of 3a square by 4 as it is, and now I have here 3a square by 2, and I have 3a square by 2. So what am I going to do is I'll be taking, if I take 4 as LCM, so it will become what, 6a square here and 4. So now they'll add up, I'll have 9a square. So I'm just writing it here directly, b minus a cube plus b minus a b square minus 4 of ab plus 9 of a square by 4. I'll keep 4 out, like this. Okay, now if I simplify this, no, I have to multiply only, so that's the only option I have got. Okay, so let's multiply only. That's the only option we have got, because this is fourth order thing. So b minus a as it is outside. So when I take the LCM now, so it will become what? So I'll put 4 outside. So I'll have what? 4a cube plus, now it will be what? b cube minus 4ab square plus 9a square b and then minus of ab square, then we'll have plus of 4a square b, and then again we'll have minus of 9a cube. This is what we get. Okay, so now let's see how many terms can be cancelled out easily. So this is ab square, so this will become what? 5 times. 5 times of ab square. Similarly, this will become what? 13 times. 13 times a square b. Okay. This is what? Minus of 9a cube. And this is what? 4 times of a cube. This will cancel out and it will become what? 5 times. 5 times of a cube. And this is b cube minus 5a b square, and this is 13a square b. So these sort of terms we are going to get. So now tell me, how can we take the terms out? We can do is b cube 5 ab square 13 left. Then just check, are we getting the 13 only or some other term? Okay, sir, not sure about 13. b cube minus minus of 4ab square, minus of 4ab square, then plus of 9a square b. This is positive 9a square b. Then positive 4a square b. It will be 13 only. It will be 13 only. So if I try to, it turns out minus 4ab only. Correct, it is minus 4ab only. I hope we have not committed any sort of calculation mistake, because it will take time to go back. Okay, if I take common from here, what I'll do is I'll just check or something. B square plus a square 2 b plus a multiply, what do we get? B cube ab square plus, that's what we must. That means for sure we have made some sort of calculation mistake. There is a very small mistake calculation. So let's do one thing. Let me just cross check the calculation quickly. There is a problem with the formulation. Shit. We spent a lot of time in this. N cube and 12 plus 1. Right. The price of the very first term, a square into h square, last term h square into 3a square h. Take common, it will start from 1 to n. Absolutely right. 3a square 1 square 2 square, correct. Absolutely right. You will get this n to n 1 plus 1 by 6, correct. And this is 3 by 2, absolutely right. So we have first term h into n minus a, and this is 4 times, so b minus a raised to 4, correct. And this becomes what? 1 plus 1 by n square by 4, absolutely right, plus 3a square by 2, absolutely right here also. And n common, take n common, so it becomes n square h square, correct. And we have what? 1 plus, absolutely right, plus 1 by, this is 3 and this is 6, so 1 by 2, absolutely right. Then a, correct. Then we take n cube common, so it becomes what? 1 by and as it is common, so 1 by 1 n and 2 plus 1 by n. Absolutely right. When you put n tends to infinity, so it becomes 0, 0, 0. So it remains only 2, and 2, 2 will cancel out, it becomes only 1. Absolutely right here also. And this is again, this becomes 0, correct, and 0, absolutely right. So B, right, this is correct. This is also correct, the term is correct, and this is also your final term is also correct. Okay, so let's check. I think, while taking the commons and all, I guess we must have made a mistake, and let's check that for b minus a, I have taken common, so a cube plus b minus a cube by 4, correct. 3a square by 2, b minus a, absolutely right. Absolutely right, this is the correct term, and plus again a b minus a cube, absolutely right, also correct. So what I can do from here is now taken b minus a common from the last 3 terms. When I take b minus a common from the last 3 terms, I've got the b minus a square by 4 plus a square by 2, absolutely right. A into a, correct. Okay, I think we must have made a calculation mistake here. So let's quickly cross check it. So what I'll do is I'll just erase it again, and I'll do it quickly, because there is a very small mistake which is see, we are getting almost the approximate correct answer. It just there's some simple mistake is there, which is making the entire question go wrong. So these type of questions you might get, obviously not in the JEE for sure. You might get these sort of questions in your boards sometimes. So this is what, let's take your h is your LCM. When I take LCM, so what do I get? B square plus a square minus 2ab okay, plus 6a square plus 4 times ab minus 4 times a square. So what do I get now? So this is 2ab and this is 4 times ab. So we'll have positive of 2ab. Okay, and this is cancelling out. We'll have 2a square and 2a square, and this is 3a square. Basically, finally we'll have 1 by 4 b square plus 3a square plus 2 of a. This is what we are going to get. See, that's the mistake, and that's the mistake which is creating the problem, the entire mistake. So here we are getting this term, and whereas we were supposed to get this term. So this is the calculation mistake I made. I'm really sorry guys, really sorry, and we wasted almost 3-4 minutes while investigating this 2ab. Now let's quickly multiply this with a minus b, b minus a, sorry, b minus a. When we quickly multiply this b minus a, I'll again get some free space for ourselves for the calculation. Okay. So when I multiply this with okay, so when I multiply b, so I have got what? Quickly b cube. Then we have twice of ab square plus 3 of a square b, and then we'll have minus of ab square, and then minus of twice of a square b, 2a square b plus twice of minus again, minus of twice of a cube. So that's what we are getting. Okay, so I have taken I multiplied with b minus a, and this is what we, sorry guys, again. And this is, see, this is what I just multiplied b minus a with this. Okay, so this is the only multiplication. Now if I am going to take the LCM, so I have to write what, 4a cube. Okay, now let's check, quickly check. So this is what, minus 3a cube, this is 4. So what we'll have the final terms b minus a by 4. We'll have only a cube. Okay, and what are we going to have? This is 3a square b, and this is what, minus 2. Okay, so we'll have only one a square b. Okay guys, and now we have a minus ab square, and this is twice of ab square. Okay, this will cancel out, so we'll have what, ab square also, and finally b cube. Yes, and this is right, this is absolutely right. What you can do now is, if you want to feel like, if you want to multiply it, fine, if you multiply, otherwise you can clearly factorize. Now you might say, how? What you can do is, from the first two terms, you can take a square common. When you take the first two terms, when you take a square common, so the factorization you get like this: a square plus b square into a plus b. So that's what you get. When you get this sort of thing, what you can do, so this becomes a square minus b square thing, and then this also multiplies. So finally what do you get? We get b raised to 4 minus a raised to 4 divided by 4, and this is what your what, and you can cross check it from your antiderivative also, because x cube's antiderivative is what, x raised to 4 by 4. Now you just need to apply the limits. Second theorem, you can use your second theorem and you can verify your answer. I'm sorry guys, we took a bigger question, and I'm really sorry for that, but it's good for learning. Let's move ahead. Okay, let's solve this question. This is the question which is what? Which is exactly opposite what we just did. We were solving what? We were solving the limits of sum to get the definite integration. Here, limits of sum is given to you. You have to solve it. Now we might use our definite integration. Now how? I told you, if you remember, we should get this sort of term. Limit n tends to infinity, 1 by n, that should be common, and that should be kept outside this summation, starting from 1 to this r, starting from 1 to n, and we should get f of r by n. This is what we need to get. Okay guys, so let's see how can we make it. So when I look at this, it seems like this is n plus 1 and this is what, n plus 2. So that means there is addition, and here as you can see 2 to 4, and this is the last term is 6n square. How can we get 6n square? Yes, one way is n plus n and n plus 2n. So this term is working as GP, right? And whereas this is working as your normal AP, the first AP. Fine, so let's write it down. The limit n tends to infinity, you have n like this, summation starting from your r 1 to n, 1 upon n plus r, and then n plus twice of r. Correct guys? So this is the term. Now the challenge for us is how to get r by n and how to get 1 by n outside. What I can do is, since in the denominator I have two n terms, let's take common n from both the terms. Let's take, so limit n tends to infinity, n upon n square, r starting from 1 to n. Now it becomes what? 1 plus r by n, then 1 plus 2 by 2r by n. Okay, so that's what we got. Clear? Now as you can see, now this looks like as a function of r by n, and here we are getting 1 by n clearly. So now I can directly write it as definite integration. Limit will be 0 to 1, 1 by n will become what? D of x, and this is what? Your function 1 upon 1 plus x and 1 plus twice of x. Now tell me, how do we solve this? Very easy. Either you can use partial fraction if you feel like, if you do not want to solve it by partial fraction, then just manipulate something. How can we manipulate? One way to manipulate this is 0 to 1, twice of 1 plus x. So 2 plus 2x minus 1 plus 2x. Like this. D of x. Now let's divide it 0 to 1. 1 by x will cancel out. So finally, what will you have? 2 upon 1 plus 2x d of x minus of integration 0 to 1. 1 plus 2x will cancel out. So we'll have what? 1 plus x d of x. Okay. Now if you want to integrate it, what it is? It is 2 upon 2 ln of 1 plus 2x. Now you would say how? It's linear function, and whatever is multiple, whatever the coefficient of x is, that comes out as in denominator, right? In derivative it gets in multiplication, whereas in integration it gets in division. So 2 upon 2 ln 1 plus twice of x. Limits 0 to 1 minus, this is what, ln 1 plus x, limits 0 to 1. Let's solve them. So when we put, so we have ln of 3 here, and when I put 0, ln 1, 0, no. When I put 2 here, so when I put 1, so I get ln 2 and again 0. So final answer is what? ln 3 by 2. So that's the final answer you will see. That's it. Okay. Easy question. I know that was a very easy question. Let's move ahead. Let's solve another question. Try solving this question. Tell me, how would you solve this question? Tell me, how would you solve this question? Very easy. Again, let's focus on one. This very same thing. Wait, 1 upon n summation r starting from 1 to n, limits n tends to infinity, f of r by n. Let's focus on this. So limit n tends to infinity will remain as it is, where as you can see it is 1 upon n square and it becomes 1 upon n here 2. So here the coefficient of sec square is what? R by n square, right? Into sec square, it is 1, 4 and it became 1. So that means it is r square by n square. Correct? Fine. And this is the summation you are getting. Starting from 1 to n, right? Let's do one thing. Let's pull out 1 by n. When we pull out 1 by n, so what do we get? Limit n tends to infinity. 1 by n is out. Summation starting from 1 to n. R by n sec square r square by n square. Correct? Okay guys, now let's move ahead. See, as you can see, this looks like as a function of r by n. So let's write it as definite integration. So 0 to 1, this become dx, and we have x into sec square x square. Now why I'm doing all these questions, I'll tell you the reason. So reason is, sometimes you might get these sort of questions in the examination. You should know these are the questions, those will be solved by definite integration. Don't think that these questions are from limits and waste your time. Okay, so this is what? This is algebraic, this is your trigonometric. What do we need to use? We need to simply use integration by parts. So let's use it. So x into 10 of, okay, hang on. What it is? This is x square. Hang on. We can substitute it. So x square is what? T. So it becomes what? 2x dx is equal to dt. So x dx will become what? Dt by 2. So dt and by 2 will come here, and we'll have what? Sec square t. Okay. Now, one thing I would like to emphasize upon, whenever you are solving definite integration problems, always change the limit whenever you are changing the variable. Whenever you are changing the variable, what I mean to say is whenever you are substituting it. So here, as you can see, here you substituted x square as t. So for the lower value of, for the lower limit of x is what? 0. So lower limit of t will be what? 0. What is the upper limit here? 1. So 1 square is what? 1. Clear? Now let's integrate this. 1 upon 2. Sec square t is what? Your tan t. Limit 0 to 1. Let's put it 1 by 2 tan of 1. So this will be your final answer. Okay guys? Hope you guys have understood it. Clear? If you have any doubt, you can ask me. Okay guys, so I'll give you one question for you. You solve that question. Here is, try solving this question. Just give me a moment because my battery is about to, so my phone is running out of battery. So just give me a moment and I'll just put my another phone on live. Meanwhile, you start solving this question. Okay, so I'll just give you the hint. You can try this question at home also. We'll not waste much of a time here in these questions. So see, it's all about, as you can see here, things are in multiplication. They are not in addition. They're not in summation. The problem comes, how will we get these terms in summation? Think. The only way is if we take the log. Fine. Let's say this is what? Limit L. Let's take the log. Log of L will be what? Limit n tends to infinity. But before that, what I'll do is I can take this n inside. When I take this n inside, so log, this 1 by n is there, right? When I take this n inside, it becomes what? N raised to n, right? And 1 by n is the exponent, so that would pop out, that would come here. And what we will have? We'll have 1 plus 1 by n. We'll have 1 plus 2 by n. Similarly, we'll have 1 plus n by n here. Now the thing is, since it's log and these things are in multiplication, so you can write them as addition. So I'll just help you out with this L, limit n tends to infinity, 1 by n as it is. Now we'll have summation starting from where? 1 to n, and what will be the term? Log of 1 plus r by n. Simple. So this will be what? Integration d of x 0 to 1, integration of what? Log of 1 plus x. That's it. Now integration of log of 1 plus x is easy to calculate, right? You can use integration by parts and you can get the answer. Okay guys, so when you get the answer, since as you know this is what? This is equal to log of L. Whatever answer you get, take the exponent, take the exponential, then only your question will be completed. Here guys? Okay, let's move to our next question then. Let's see this question. You guys can try this question again at home. I'll just give you the hint so that you can just try it out. Again, the main focus is we have to take n common, 1 by n common should. So let's do one thing, take n square common. When you take n square common, it becomes what? Summation k is equal to 1 to n. When I take n square, so 1 by n I keep here and the another n will go in the numerator. So it becomes what? 1 plus k square by n. See, as you can see now, this has become of what? K by n. You can write it as f of x. So integration will be what? 0 to 1 x 1 upon x square dx. You can easily substitute this as t. solve it. Simple. You can try these questions at home. I'm not solving these questions because these questions are for practice. You can solve them. Okay, what about this question? Again, this is also same type of question. How this is n factorial, when you'll open it right now has become what? The same right hand side. So that means your variable doesn't make any difference. The same. Now let's prove this one. How will you prove this one? Any idea? Yes, I'll tell you. It's very easy. What is the second theorem says? Second theorem says the integration for this will be what? Antiderivatives value at b minus antiderivatives value at a. Right? Now look at the right hand side. Right hand side says minus what will be the antiderivative of f of x? Again, capital F. What is the upper limit here? A. What is the lower limit here? B. That's it. It will be what? F of b minus f of a. That's it. So both are same. Proved. What about this one? How will you do it? Again, it's simple. You can take geometrical interpretation. Since it gives you the left hand side gives you the area between A and B, right? And just imagine if C is any point between A and B. C is any point between A and B. Then the area under the curve will be, we can just break that area, right? We can calculate the area from A to C, then area from C to B, right? This is the geometrical explanation. Now, I have been asked one question in the morning that, sir, can we take this C outside AB also? We can take, given the fact your function is defined in A comma C interval. Just check your function is defined in A comma C interval. If you want to put this C outside, you can put, but make sure that this is defined. This is your function is defined. Okay. Now let's go to one of the best properties of definite integration is this. F of x is equal to for integration a to b. F of x dx is equal to what? This is equal to f of a plus b minus x dx. Now how will you prove this? Any idea? Any idea, guys? How will you prove this? Okay, I'll tell you. What you can do in this is, you can substitute x as a plus b minus t. Okay, so you will have dx is equal to minus of dt. Fine. So let's put it here. So dx will be what? Dt and minus out, and f will be what? A plus b minus of t. Fine. Now let's see the lower limit. What is the lower limit here? Lower limit will be the moment I put x as a will cancel out. So t becomes what? B, and upper limit becomes a. Now, what is our second property? Second property says if you flip the limits, you get minus sign. So minus minus will become plus. So a becomes a, this is b, and what do you get? A plus b minus t, dt. Now, as we know, using our first property that yes, variable doesn't make any difference. So a to b, f of b plus a minus x dx, and hence proved. This property is also proved. Why I am proving all these properties? Because it might happen, and it happens actually a lot. In calculus, you get these sort of questions where they ask you to, instead of asking you to find out direct functions value, they give you a general function and they ask you to prove some properties, or they give you options and ask, tell me what all options will be correct. So that's why I am doing all these proofs, because you guys also become intuitive and how to approach these sort of questions. So let's prove this property also, where 0 to 2a f of x dx is equal to what? 0 to a f of x into d of x, okay, plus integration 0 to a f of 2a minus x. So what I'll do is, first as I can see, it is starting from 0 to a, right? So that means it's better I break it first. So left hand side will be written as 0 to a f of x dx plus integration a to 2a f of x dx. Now what I'll do is, because I have to make what 2a minus x, right? No point in a plus b minus x, no point in doing that. If I put, let's say, x as 2a minus, I put 2a minus t. So a, I'll get a, yes, 2a minus t will work. So you will get dx is equal to what? Minus of dt, correct? So this will become, I'm just solving this part only, this part. Second. So this will become what? The lower limit will become, the moment you put a, so t will become what? Your a. The moment you put x is equal to 2a, the upper limit of t will become what? 0. F of 2a minus t and dt minus will be popped down. Correct? Now, again the second property, let's flip the limits. The moment you flip the limits, this will again come back to the same. 0 to a f of 2a minus t dt. As we know, according to our first property, variables doesn't make sense. Yes? Okay. Okay. So now I'll tell you one more extension in this. As you can see, it is what? 0 to a f of x dx, 0 to a f of 2a minus t dt, right? Now, if f of a f of x actually, f of x is equal to what? F of 2a minus x. If that is the case, then what will happen? This integration, the entire thing will become what? Twice of 0 to a f of x dx. Remember this. If it is the other way around, what I mean to say is, if f of x is equal to minus of twice of a minus x, then what will happen? Then this integration will be 0. Okay, so remember this. These are the two important results you can use while solving questions. Otherwise, if you remember the property also, that is also more than enough for me, because that will help you to solve many questions. Okay, so now shall we move ahead? Shall we solve more questions? Okay, let's solve more number of questions. Yes, wow, we have more set of properties also. So let's talk about these properties. Now tell me, how can you prove this? What I think is, let's write it like the previous property, because it's 0 to a, 0 to a, right? So I can write it like as 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now the thing is, how can I make this and this as a plus x and a minus x? Yes, one way. I can put x as a minus t. Let's put it, when you put it a as x as a minus t, so your lower limit becomes what here? Becomes what? Dx as minus of dt first. When you put 0 here, so t becomes what? A, and it becomes 0 minus of dt. This is what? F of a minus t. Okay. What about the second one? Again, we a to 0 f of 2a minus a plus t dt, and we'll have minus dt, so it will be, oh, so a will cancel out, so 2a minus a, we have a plus t. So finally what we'll have, and we'll have flip over also limits, so 0 to a f of a minus t dt plus f of a plus t dt. That's it. That's proved. Now let's take this one. Otherwise we would have had minus a to 0. Okay. So let's do this. So now when I do that, so now my lower limit will become what? A. upper will become 0, minus of dt this, and f of minus of t, correct, plus 0 to a f of x dx. Now you can flip it. When you flip the limits, what happens? 0 to a gets common and you get what? F of x, plus, since variable doesn't make any difference, property number 1, dx. Now look at this. If this gives you what? If this gives you 0, what does it mean? They were odd. If this gives you some certain value, then it will be what? Twice of f of x. That's it. Clear? Hi Prakash Kumar Rai, how are you? The name is Prakash Kumar Rai. Prakash, are you up for the marathon session? Because we are just doing the properties right now, and post the properties we'll be solving many questions. Now let's solve this, the period one. Starting from a to a plus nt f of x, where t is the period. This will be equal to this. So now how can we prove it? Any idea? Yes, I'll tell you. Let's start from a to 0 f of x dx, then integration from 0 to again t f of x dx, integration t to 2t f of x dx. Are you having audio problem? Let me just check. I'll check here also. Hello? No, it's perfectly fine, Prakash. Prakash, it's perfectly fine because I am also watching myself live on YouTube. Audio connection problem at your end, or because I am watching myself live here over the phone also, so that I can read your comments. See, it's perfectly fine. What you can do, you can refresh, check your internet speed. This will be what? Again 2 to 3t f of x dx. I guess you are having video, what I'm saying is I think you are having some internet issues. Check your internet. No, it must be 100 Mbps. But check what is the current speed right now. Check the current speed. If you want, I'll just check at my end also, because mine is, I know it's perfectly fine, but still, if you're saying, if you're insisting, I'll just check it. Wait. It's good. Oh, 100 kbps. Dude, 100 kbps is very low. 100 kbps is very low actually. 100 mbps would have been better, but kbps is actually very less. You try using your data connection, maybe that will help you. And similarly, we'll have till this thing, we'll have till when? We'll have this thing till we have nt n minus 1 t2 nt of x dx, and final one is starting from nt to a plus nt f of x dx. Now all these terms will give me what? They'll give me 0 to t, 0 t. Integration 0 to 2 f of x. You can try. How? For second one, you can substitute what? X as small t plus capital T. For this, you can try t plus 2t. You can try it out. Prakash, I would suggest, buddy, I would suggest you, it's better you, I would suggest it's better you check, check your internet connection, because that's the only issue right now. Because I just checked it, my internet is functioning pretty fine. See, you can hear the audio also. Now the thing is, this is 0 to a, right? And this is what nt to a plus nt. So what I can do is, I can substitute for this. See, for this one, for the entire one, I will be getting what? N 0 to t f of x dx. Another thing is, for this, what I'll do is, I'll focus on this last term. Let's substitute x as nt plus small t. So when I do that, so I get dx is equal to dt, and my lower limit becomes what? My lower limit becomes, the moment I put t as nt, it becomes 0 here, and a plus nt, when I put a plus nt, it becomes a here, and f of x, instead of f of x, I get t plus n capital T and dt. So since it's a periodic and t is a period, so f of t small t plus n capital T will give me what? F of t only, right? So let's write it here. The last term is here. So 0 to a f of t dt. Using our first property, we can change the variable. Now see the limit. The limit is starting from a to 0, and it is 0 to a. And the addition, what would we get? Limit, upper limit and lower limit both are same. So in that case, what will be your integration? Definite integration 0. So these two terms will give you what? 0 value. So that's your answer. You can use this property to prove the later two properties easily. Okay. Now, all set, all typed up, ready with all the properties. Okay. So let's solve the questions now. Here comes the very first question. Now tell me, how would you solve this question? Tell me guys, how would you solve this question? The approach to solve this question would be, first let's try to, as we have earlier done also in indefinite integration, since it's 1 to infinity, obviously if you are planning to apply properties like a plus b minus x and all, they're not going to work for sure. It's better we simplify it first. So it's inverse, so I can write it as d of e raised to x plus 1 plus e raised to 3 minus x. See, it says e raised to minus x, correct? So let's do one thing, let's take the LCM here, and e raised to x will come up. I've taken the LCM in the denominator, so it becomes what? E raised to 2x plus 1 plus e raised to 3. Now what I can do is, I can take e square as common, ex as common. If I take ex as e common, I can substitute ex as t. Let's substitute t. So it will become what? Ex dx is equal to dt. Fine. And the derivative is available in the numerator. Now, since you are substituting it, you have to change the limits also. So e raised to 1. E raised to 1 will be what? E. E raised to infinity is what? Will be infinity. So dt. We'll have what? Here t square into e plus e cube. I can take e common easily. So the moment I take e common, so it becomes e infinity dt. T square plus e square. Alright, this looks like what? This looks like as if it's a what? Tan inverse formula. So 1 by e 1 upon a into tan inverse x by e. So here t by e. Limits e to infinity. Let's put them. So I have 1 upon e square here. 1 upon e. The moment I put infinity, what do I get? Pi by 2 minus the moment I put e, I get pi by 4. So this is pi by 4. Final answer will be what? Pi by 4 e square. This will be your answer. What is the correct option here? The correct option is A. Prakash Kumar Rai. Did you get the question? Buddy, did you get the question? Okay. Let's move ahead. Let's solve another question. Here comes the other question. The value of definite integral is integration 0 to limit is given to you root ln pi by 2 cos e x square into 2x into e x square dx. Okay, so when you look at this question, don't you think the derivative of this is available here, right? We can easily directly substitute here. E raised to x square is, let's say, t. E raised to x square to twice of x dx will give you what? dt. Okay, so integration limit, if you want to change, the moment you put 0, you get what? E0. E0 is what? It will give you what? 1. And the moment you put e x square, this x as root of ln pi by 2. So your will become what? Ln pi by 2. This will cancel out. You have only pi by 2 left here. So cos of t dt, that's it. Okay, so what is the integration of this? Simple integration. Antiderivative what? Sin t. So sin t, let's put the limit 1 to pi by 2. The moment you put pi, it becomes 1. Sin of 1. That's it. So what is the correct answer here? C. C is the correct answer. Done. See, very easy questions are there, right? Let's move to the next question then. The value of the definite integral is what? Integration minus 1 by 2 to pi by, so minus 1 by 2 to 1 by 2 sin inverse 2x minus 4x cube minus cos inverse 4x cube minus 3x. See, the moment we see this, because we know the property what? Minus a to a, odd even thing, right? Then check. When you check odd even functions, so obviously this is your odd functions. So the integration of this is what? Integration of this is going to be 0 for sure. Why? Because this is odd. But what about this? You put minus x, neither it is even nor odd. So how to solve it? So let's do one thing. Let's try focusing on this, because integration of this first term is 0. So let's not focus on this. So we have to solve this thing. Minus 1 by 2 cos inverse 4x cube minus x dx, and let's say this is okay. Now when I put let's say, let's use property, which one? F of a plus b minus x 1. Property a to b dx is equal to what? Integration f of x dx, a to b. Let's use this property. When we use this property, what do we get? I is equal to minus 1 by 2 cos inverse minus half 0 x minus x. So we get what? Minus 4x cube plus of 3x. Okay, so what we can do is, here I is equal to, when do you remember this cos inverse property? What? Cos inverse minus x is what? It is pi minus cos inverse x, correct? So let's do one thing. You can take minus common. The moment we take minus common, what do we get? Minus half, and this is half, minus is already there. We take minus common, so what do we get? Cos inverse minus of 4x cube minus 3x, right? Bracket close. What I'm doing is I'm rewriting it like this. I take minus common, so 4x cube minus 3x. Like this. I'll be writing inside cos inverse. Okay, so I can write it as pi minus what? Cos inverse 4x cube minus 3x, right? Now see this thing. This is I, and what it is, if you check this, this is what? Minus of integration minus 1 by 2 to 1 by 2 pi dx. This is what? Minus went inside, and this is what? Minus of cos inverse 4x cube minus 3x dx, limit again from minus half to half. Now check. What do you think? This is what? This is actually the I only. Because see, what was the I? Minus of cos inverse this, right? Sorry, what was the I? This was the I. This is what we assumed, right? I is equal to what? Minus of integration minus half to half cos inverse this. As you can see, this is what? Same thing. Now let's take this thing to left hand side. So what do we have? I, and this is what? Minus of I. We'll have plus of I here, and let's integrate this. Minus of pi x, limit minus half to half. So what do we have? Twice of I is equal to minus pi. Let's put the limit. Half minus half, we get only 1. So I will be what? Minus pi by 2. This will be your answer. Hi Rajshri Senapati. How are you, Rajshri? The correct answer here would be B. Okay. So Rajshri, are you up for the questions? We are solving now because we have covered all the theory for definite integration, all the theoretical part, all the properties. We proved all the properties. Now we are solving questions. So if you're free and ready to learn, you're always welcome, and you can solve questions with us. This is the question. Rajshri, are you there? Let's solve this question. So how can we solve this question? Very easily. So the function is what? Function is minimum of these three functions. So let's do one thing. First find out the minimum of these functions. So according to that, we'll break our limits. Cool. So let's do it. First, and interval is what? Minus 1 to 1. So minus 1 to 1. Between minus 1 to 1, if I draw mod of x, so how will it be? It will be like this. How will I draw 1 minus mod x? Does anyone know? It's very easy. Those who have studied functions from me, they know. Here it is minus of mod x. Whenever we apply minus to any function, what happens? The function gets flipped. Whatever is above the x-axis, that goes to below the x-axis, or whatever is there below the x-axis, that goes above the x-axis. Okay, so let's do it. Then there is a constant being added. That means then there should be a shift in y-axis, right? So basically mod x is like this. When we put minus mod x, that goes down, and then there is a shift of 1 in positive y direction. So I'll draw the second curve using the different color. So it will come here, and I'll draw it like this. Okay guys, now let's draw the third curve. Third curve is a constant, 1 by 4. So let's draw it also. 1 by 4. So 1 by 4 will be This is, they will intersect where? Just to find out the intersection point, what I'll do is, let's say find out first this one. So since it's a positive side, x will be equal to 1 minus x. So we have 2x is equal to 1. So x will be what? 1 by 2. 1 by 2. So certainly if this is 1 by 2, so our point will, this line will be below this. So now let's find out the area which is minimum. Let's find out the curve. So what I'll do is I'll dark the area under this curve. So minimum. So among green, blue and red, which one is below right now? The lowest one is green. So this is the area actually. Now from this point onward, how to find this point? This is 1 by 4. So this point will be what? 1 by 4 is equal to what? 1 plus x. So x will be what? Minus 3 by 4. Or minus 3 by 4. Now from here to here till here, and what it is, this point is minus 1 by 4. You can check. And now among green, blue and this red, which one is having the minimum value? Obviously the red one. So we'll have this, right? Similarly on the right hand side, since it's a very symmetric curve, so we'll have this area. Okay guys, so now if you want to calculate the area, so one way is we can use graphical method, another way is we can using our mathematical form. So I'll use first graphical method so that you see the answer. See what it looks like. It looks like as if it's a trapezium. So what is the area of trapezium? Half into addition of parallel lines. So the lower one is having length 1. The upper one is starting from 1 by 4 going till 3 by 4. So it's half. 1 plus 1 by 2 into the distance. Distance is what? 1 by 4 it is given. So the answer is 3 by 2 into 3 by 2 into 1 by 2 into 1 by 4. The answer is what? 3 by 16. But since the entire area is what? Twice of this. So the entire area will be what? Twice of 3 by 16. So basically 3 by 8. Now if you want to solve it mathematically, so how will you solve it? Easy. So let's do one thing. Let's calculate the area here, which is there on the left hand side of the y-axis, and then I'll twice that area. Okay, so twice of this area. So I'm integrating starting from -1 to 0 f of x dx. Okay guys, so it will be a twice of, now I'm breaking the limits because my function is being changed. So it is going from -1 to minus 3 by 4, and this is what? This is 1 minus, which line is this? 1 minus of mod x, right? Here mod will be, x will be what? Negative, so negative sign, so it will become what? 1 plus x dx. Then we have a constant 1 by 4 dx. Then we have again a straight line. What is a straight line? X is negative, so yes, minus of x, minus half of minus of 4 till 0 dx. Let's integrate it. Twice of, if we integrate it, what do we get? X plus x square by 2, limit -1 to minus by 4, limit 1 by 4 into x, limit -3 by 4 to -1 by 4, plus this is minus x, so I'll write it like this, minus x square by 2, limit -1 by 4 to 0. I hope everyone is clear with this fact. Clear guys? No one is having any doubt, right? Okay, let's put the values here. 2. So it becomes what? -3 by 4, and when you put it plus 9 by 16, and this becomes 32, minus becomes plus 1, then minus half. plus 1 by 4 minus 1 by 4 plus 3 by 4 half. Okay, minus 0. Then we already have 0 minus 0 minus so 0 minus, so minus minus will become plus, so 1 by 4 square, so basically 1 by 1632. This is what we get. Let's solve it. Half, if you solve this we get half, so we'll get only positive half, and this is 3 by 4, and if we solve this, what do we get? We get minus 1 by 4. Okay guys, and if we solve this and minus 1 by 4, if we solve minus 1 by 4 and this, what do we get? Positive of half into, so it's half and this is complete, so we'll get what? Minus 1 by 8 only, minus 1 by 8. Okay, minus 1 by 8. Let's solve these two terms. If we solve these remaining three, so what do we get? 2. I can take LCM out, 32. So when I take 32, so 9 plus 1 minus of 4, right? So this is what? 10 minus 6 by what? 16. We solve it, what do we get? 3 by 8. See, we are getting the same answer, right guys? So choose your way. But obviously in the examination, if anyone would ask me the kind of functions they have given me, certainly I'll go with this graphical approach, because that would save a lot of time. But this is, see, there is no necessity that you would be getting this sort of simpler functions. You might get difficult functions also. So you should know the way how to solve it. You should know how to break the function, where they are intersecting. You should know everything. So that's why I have solved it mathematically also, because that would just give you the confidence, that would show you the path, the process, how to solve these sort of questions also. Okay, now let's move ahead. Now this is our next question. Now we have to find the value of k. Now the thing is, we just need to do the definite integration and we will find the value of k. Now tell me, how will you solve this question? Any idea? See, what I see in this, the very first thing is, because if I consider ex as a t, derivative is not there. So let's do one thing, let's take it down in the denominator. So 0 to 1 dx e raised to x. Now yes, we can factorize them. Yes, we can do that. 0 to 1 e raised to x plus 1 minus e raised to x upon e raised to x into 1 plus e raised to dx. Okay, now let's divide. When you try dividing it, what do you get? So 0 to 1 e raised to x plus 1, that will cancel out. So what do we get? E raised to x, that goes to up e minus x into x. That is easy to integrate. Perfect. Minus, then we have got e raised to x, that will cancel out. So we have what? Dx 1 plus e raised to 0 to 1, right? And this will cancel out, and this. Now the thing is, how can we integrate this? Yes, there is a way to integrate this. If I divide both numerator and denominator, we can do that also. So the integration for this is what? What it is? Very easy. So e raised to minus x. Since minus 1 is there in the multiplication, so that would come in the denominator. So overall we'll have minus sign here. Limit 0 to 1. Minus, what I'm saying here is, let's divide both numerator and denominator with e raised to minus x. Sorry, you multiply both numerator and denominator with e raised to minus x. When you do that, what do you see? This. And now it is very easy for you to substitute this, because its derivative is there available in the numerator. E raised to minus x plus 1 is, let's say, t, minus of e raised to x dx is equal to what? dt. So let's solve it. Minus of e raised to minus 1 minus of, the minus is there, so minus minus. So this will already minus will go in the numerator. We'll have 0 to now first. Very first thing, as I have always told you, whenever you substitute, you better change the limits also. So how are you going to change the limits? When you put what 0, it becomes what e raised to 0, 1, 1 plus 1, 2, becomes 2. And when you put 1, so it becomes what e raised to minus 1 plus 1. So 1 plus e raised to minus 1. Okay, and it is what t. Now the integration of this is what? It's very easy. What it is? I'm writing it here. So this is minus of e raised to minus plus 1 plus ln t and limit 2, and this is 1 plus e raised to minus 1. So minus of e raised to minus 1 plus 1 plus ln t 1. So what I'll do is I'll take the LCM here. So it will become what? 1 plus e minus ln e. So basically this will become 1. Then we have minus of ln 2. So this will give us what? This will give us 1. 1 and 1 will cancel out. So final answer is what? ln 1 plus e minus ln 2 and minus 1 upon e. So this is this value, this entire value with negative sign. This is what? This is equal to the k, and this is our value of k. Okay guys, I hope you must have got this question also. Here, let's move to our next question then. Okay, look at this question. What it says? It says if f of 0 is equal to 1, f of 2 is equal to 3, and f dash is equal to 2 is equal to 5, then we have to find the value of integration 0 to 1 x f double dash twice of x dx. Now when you see this question, don't you think when someone has given you the value of lesser derivative of f, that means someone is asking you to what? Going ahead with partial fraction, right? Because it is already multiplied with x, so that means go ahead with partial fraction. Now the thing is, which function to assume as first? So it's better we assume f double dash 2x as second. Why? Because second function only gets integrated multiple times, right? So let's do it. So integration first x as it is, when we integrate it becomes what? F dash 2x, and in integration, if a coefficient of x is there, then that coefficient comes down in denominator. Hope you remember this. Minus, I'm stating it again and again because I have seen people committing this mistake. Then again 0 to 1, derivative of x is what? 1. Again the same thing, f dash 2x by 2 dx. Solve it. Let's put the limit here. So it becomes 1 into f dash 2. F dash 2 is what? 5. 5 by 2 minus 0. Minus. Let's integrate it once again. So f dash 2x. I want to integrate 1 by 4. And this will become what? F 2x. But again 0 to 1. Let's put it here. 5 by 2 minus 1 by 4. This will become what? This will become f of 2. F of 2 is what? It's given to us 3 minus f of 0 is what? 1 given to us. Solve it. It is what? 5 by 2 minus 1 by 4 into 2. 1 by 2, 5 by 2, we get 2. 2 will be your correct answer, right? That's it. It's a good question, right? Something different. I know. Let's move ahead. Let's solve another question, another type of question. Okay, this question. You guys, meanwhile, you guys read this question. I'll just quench my thirst. So tell me, how would you solve this question? See, what this question has done is, there is a function that they have substituted 10x by 2 as t, and they got this. But when they were changing the limit, it became 0 0. When limits are same, so obviously we get 0 answer, right? Now the question is, what went wrong in this question? I'll tell you the reason. See, if you just look at the integration, the function which needs to be integrated, this function is always positive. I'll tell you why. Look at this. Cos x is what? Cos x is always between what? -1 to 1, correct? When you multiply with the -2, again will be between -2 to 2, correct? Now add 5. When you add 5, it becomes what? This. Divide by, take the reciprocal. When you take the reciprocal, it will, the inequality will change. As you can see, this will be always positive. When something is positive and it is being integrated between the 0 to 2 pi interval, and obviously this function is defined, correct? This function is continuous also, so you should get some finite value. So what went wrong in the entire process? Tell me, what went wrong in the entire process? Any idea? Okay, I'll tell you the reason. What went wrong in the entire process? In this entire process, as I told you, as one of my observations, that always check whatever is being substituted, its continuity during that interval. Now see, at when you are substituting t, this 10x by 2 as t, at pi by 2, at x is equal to pi, and we get what? 10 pi by 2. Tell me, this is defined first? No, this is not defined at all, and it is being, and the function, the entire function is becoming what? This substitution thing, this function is becoming what? It's continuous also, right? So that's the only mistake this question has. This is the question, this is the mistake which had been committed while solving the question. So as I always say, check the continuity of the function which needs to be substituted first. Second, check the continuity of the antiderivative also. Always do that. Okay guys, fine, let's move ahead. Not defined and discontinued. Okay, let's move to the next question. Sorry guys, actually my phone is running out of battery, so as I can see that I can't see you guys, I can't respond to you, but it's still, what I'll do is I'll try seeing you here on my another phone. Give me a moment, I'm just setting up. Yes. Okay, let's move ahead. Just give me a moment, I'm just setting up once again because I think there is some problem. Okay, let's solve this question. Tell me, how would you solve this question? Any idea? Any idea how will you solve this question? Okay, I'll tell you. See, in this question, you can just simply put your properties and check. How? In this, what you can do is, you can directly apply what? Which property? You can play with this property, that f of 0 to pi by 2, f of a plus b minus x. When you do this, sine of pi by 2 minus x. So obviously this will become what? Cos x minus, this will become minus sine x, and the denominator remains as it is. As you can see, this is also I. When you take minus common from this, you get again I, right? Same thing I1, right? I1. So let's take it to the left hand side. So twice of I1 is what? 0. So I1 will be what? 0. This is clear. What about I2? I2 is what? It's a even power. So even power, and you are integrating. So obviously you get positive area, but not 0 for sure. So I2 can't be 0. Do we have any option where I2 can't be 0? The only option where I2 is not 0. That means option C will be the right. But if you want to check I3, I4, we'll check. See, minus pi by 2 to pi by 2. What do we need to do? You just need to check the function is whether it is even or odd. Put minus x. You'll get what? Minus sine cube x. That means this function is what? This is odd function. So this will also go to 0. That means this is okay. If you want to check this function, how will you check I4? First of all, we don't require to check I4 looking at the options, but if you still want to check, hi Mithilesh, but if you guys still want to check, then we can do the check. What you can do is ln 1 minus x minus ln x dx. You can find the integration of these two easily, right? Very easy to be found. How can you do it? I'll tell you. So first, if you apply the property also, what it is the property? A plus b minus x. Try that out. You apply a plus b minus x property of a plus b minus x dx. Limits a to b is equal to what? Limits f of x dx. So it becomes what? 0 to 1 ln 1 minus 1 minus x. So this will become plus minus ln 1 minus x dx. Cancel out. So what did you get? Ln x minus, as you can see, this is what? Minus of I4. This was I4. This is minus I4. I4 will be what? 0. That's it. So your C is correct. We checked it for all the functions. Hi Mithilesh. How are you? I hope you are understanding whatever questions we are doing right now. Okay. If you have any doubt, you can ask me. Okay. Let's move to our next question. Here is the question. 0 to pi x into sine square x into cos x into dx is equal to. Okay. So what we will do first is, first I know we all will try to check a plus b minus x, right? Check a plus b minus x. Obviously you would not get anything like this. You get sine square x only, and you'll get what? It's cos x. So second quadrant cos will be negative, so cos x, negative sign here dx. So what it will be? You'll have minus pi constant term, then plus x sine square x cos x. No, this is not beneficial. No point in solving this ways. So what we can do is, let's do one thing. Since it's a trigonometric function and this is what algebraic, let's solve it using integration by parts. So this is your first function, so x. Here integrating, while integrating this 0 to pi sine square x cos x. Remember how we used to solve this? We used to substitute even thing as t minus integration derivative of x is what? 1 into integration of 0 to pi integration of sine square x cos x dx whole dx. Let's solve it. X, let's substitute this sin x as t. When we substitute sin x as t, when we do it, what do we get? T square and this goes to the derivative t square, so it will become what? T cube by 3 is equal to pi. Here. Okay, one more thing. Just hang on, guys. Hang on. We have to change the limit also. So when we put sin x, when we are putting sin x and t, zero and zero again. Yes, 0 0, correct. The limit will be what? 0 0. Why 0 0? And but for this what will happen? This is x, so it's better, I would suggest, since it's x and this is t, it's better you replace it. It's better you substitute it back. It's better you substitute this back. Okay, so how will I write this? X into sine of cube x by 3, limit 0 from pi, minus. Okay, now let's talk about this. So what do we have? 0 to pi. Now the thing for this is what? For this we get what? Sine of cube x by 3. By 3 will pop out here. We have dx. Now how will you integrate this? Yes, we can convert this. We can use sine 3x formula. What was that sine 3x formula? Sine 3x is equal to 3 of sine x minus 4 times sine cube x. Let's use it. So if we use it, so sine cube x is what? Sine cube x is 3 of sine x minus sine of 3x divided by what? 4. So let's substitute it here. And when we put the values here, so pi, this is 0, 0. So this goes to 0. This vanishes, this term. So minus 1 by 3. And we have what? Integration 0 to pi. We have 3 sine x dx. I have taken 1 by 4 common also here. And then we have again minus and already minus sign was outside, so it will become plus. So 0 to pi sine of 3x divided by what? Divided by 12 again. 1 by 4 and this minus 1 by 3 was there. Okay, so let's solve it. So 3 will cancel out. So what do we have now? Minus 1 by 4. The integration of sine x. Sine x is what? Cos x. Integration from 0 to, this is minus of sine x. So minus of sine x. It is minus of sine x. So we'll have what? Cos x. The antiderivative of minus of sine x is what? Cos x, correct? Okay. Plus, we'll have what? This is already 12 we have. We'll have 3 in denominator. What is the antiderivative of sine minus of cos? 3x. Limit from 0 to pi. Clear? Let's put now. Let's solve. This is when you put, so it will become what? 1 by 4. When you put 0, what do you get? Again, you get what? 1. Again, 1 by 4. Clear, guys? Plus 1 by 36. What do we have now? When we put pi, we get what? We get minus of 1. Cos of 3 pi. We get minus of 1. Already minus is there. So it will become what? It will become 1 minus. Okay? Minus. And then we have minus of cos 0. We get minus 1. Already 1 is there. Minus is there. It will become plus again. We'll have this. Okay? So 2, it will become what? 1 by 18. Fine. And this is what? Minus half. Plus 1 by 18. Let's take the LCM. LCM will be what? 18 here. This is 1 as it is. Minus, we'll have what? 9 here. Finally, what we'll have? Minus of 8 by 18. Cancel out twice. Minus 4 by 9. Do we have any option like this? Yes, we do have. D is your correct answer. Correct? I hope people must have solved this question also. Cool. Okay, fine. Let's move to our next question then. Integration 0 to ln 5 e raised to x root e raised to x minus 1 upon e raised to x plus 3 dx. Tell me, so do you think shall we apply any property? See, what I think is if we apply any property, we will not get benefited. Reason being because this square root is there. This square root is there. It will not let anything happen. Because our properties will be what? A plus b minus x like this. A plus b minus ln. It will become 5 e raised to minus x. Minus x. No, this will not help us out. What we can do is, let's try simplifying this. Let's try simplifying this. So how can we simplify it? If I substitute this as t, the derivative is available and I'll have what? Square. No, if you remember, let's do one thing. Let's first break, because it is what? E raised to x, right? So let's break this first, because I think breaking will make it easier. E raised to x plus 3 minus 3 root of e raised to x minus 1 upon e raised to x plus 3 of x. Okay. Can you try solving it? The root of 3. Actually, fine. We can solve it both ways. I'll tell you. So let's first see this approach. 0 to L1 5. And this cancels out. What do we get? This and this cancels out. So we have finally e raised to x minus 3 of x. Correct? Minus of integration 0 to ln 5 e raised to x minus 1 e raised to x dx. Okay. When I said we can solve both ways, I'll tell you how. See, its integration is easier. How? We can substitute this as e raised to x minus 1 as t square. You differentiate it and you will get the answer. But the simpler form, what I am thinking right now is, what we can do is, the simpler form, what I was thinking is, if we substitute this as t directly, because its derivative is available, and this will become root quadratic. Root quadratic solution we have already done in indefinite integration, right? So e raised to x plus 3 is equal to t. So e raised to x into dx got dt, and this is available. Now change our limit. So our limits will be what? When I put 0, it will become what? 4. Correct? Right, guys? It will become 4. 0. And now I put ln 5. The moment I put ln 5, this will get cancelled. So 5 plus 3, 8. And this has become dt. And for dt, I have what? Root of dx. This is what? T minus 3 minus 1 upon what? Upon this is your t. Okay, and this is the t. So you can solve it very easily, because it is what? Root of linear upon linear. You can easily solve it, right? What we can do is t minus 4 is as, you put t square. When you put it as t square, you get what? dt is equal to 2u du. Correct? The limit will be what? Your limit will become, when you put t as 4, so u becomes 0. You put it as 8, u becomes what? So what do you get? 2u du is there, du upon this t is what? This becomes u square plus what it is. Now it is u square, twice of u square, and u square plus 4. And this is easier one, right? Kaise? 0 to root 2. This can be written as twice of u square plus 8, right? 8 it will become plus 4 and minus of 8. and you can divide with u square plus 4, and here also u square plus 4 integration du. Now you can easily integrate this also. How will you integrate this? See, this can be integrated like this. U square cancel out, so you'll have what, 2, and integration is u 0 to here. Okay. Now from here also minus of what? This is what, 8 times, right? 8 times. This is what your formula for what? The tan inverse. So how will you write it? So 8 upon 2 tan inverse u by 2 and u by 2 integration from 0 to root 2. 0 to root 2. When you put root 2 here, so 2 root 2, 2 root 2, and this is 4, and tan inverse 1 upon root 2, then 0. 4 minus tan inverse. I guess we must have made some mistake. Give me a moment, guys. I think there is some limitation, some limits mistake we have committed. Let's not just hang on, guys. I guess we must have committed very small mistake. E raised to x plus 3 as t if we substitute it. So when you put x as 0, our limit becomes 0 as 1, 4, and dt, and this what, t minus ln 5. When we put ln 5, e will cancel out, so 5 becomes 5 plus 3. See, that's the mistake. So t minus 4. So t minus 4 is what? 4. So u square is what? 4. So basically limit will be what? 2, not root 2. So that's the mistake. I was telling you guys, there is a mistake. This is what? 2. This is also what? 2. Let's solve it now. So when you put 2, so we get what? 4 minus 0 minus 8. This is 4, and tan inverse. Let's solve this. Tan inverse 2. So pi by 4 minus. When you put 0, so tan inverse 0, we get 0 only. Okay. Let's solve it. 4 minus 4 will cancel out. So 4 minus pi. So 4 minus pi will be your answer. Do we have any option like this? Yes, we do have A. A is the correct option. Okay. Fine, guys. Easy question, right? So let's move to our next question. Integration 0 to pi by 2 dx a square cos square x plus b square sin square x. How to solve this question? I guess you guys must have remembered it. In indefinite we used to solve them. How? We used to convert this into what? Sec square and tan square. How can we do that? We'll have to divide both numerator and denominator with cos square x. So this will become what? Sec square x dx upon a square plus b square what? Tan square x. Now we can substitute tan x as t, so it will become what? Sec square x dx as dt. One more thing, if you see when I'm substituting tan x as t, as you can see between 0 to pi by 2, this tan x is defined. Okay. So remember this, just cross check it when you are substituting it, just give a look, that's it. What I mean to say is, at least you will not commit mistake. So it will be what? It will be dt. Let's change the limit. So at 0, 0, at pi by 2 it will become infinity upon a square plus b square t. Okay. It looks like your tan inverse formula correct. Let's pull out b square first. So now 0 to infinity dt a square upon b square plus t square. So what is the formula? What do we have? 1 upon b square, 1 upon a. So a, b here, tan inverse. T upon a. So a is what? A by b. Okay, limit 0 to infinity. Let's put it. This will cancel out. So we have ab. And finally here we have what? The moment I put infinity, it becomes tan inverse. Tan inverse infinity is what? Pi by 2. And the moment I put 0, we get 0 only. So final answer is what? Pi upon twice of AB. So this is the final answer for this question. Got it, guys? चलिए अगला question करते हैं. Does anyone have any questions? Give me a moment. I think there is my video. Yes, now perfect. Let's solve another question. Sine inverse root 1 minus x square root sine inverse upon 1 minus x square root 1 minus x square and 0 to 1 by root 2. So the very first thing, obviously, if you are planning to apply any sort of properties are not going to work, because it is what? A plus b minus x. If you are checking that property, that is not going to work here. So but the better thing, what I see here is that derivative of sine inverse in x is available, right? So let's substitute it. Okay, now when you are substituting it, just check in this interval 0 to 1 by root 2. Sine inverse is defined? Yes, it is defined. What it is? Dt, right? Integration 0 1 by root 2, when you put it becomes what? Pi by 4, and this is what? Dt upon sine inverse x was t, substituted t dt, and this is what? 1 minus x square. So 1 minus sine square t. 1 minus sine square t will be written as what? Cos square t. It will go up 0 to pi by 4 t into sec square t. How does it look like? It looks like as if we are doing integration by parts. Let's do it. T into sec, you get what? 10t. 0 to pi by 4 minus derivative of t is what? 1. 0 to pi by 4 tan of t dt. What is the integration of tan t? Does anyone remember it? Let's put the values here first. So pi by 4 into tan pi by 4 is 1 and then 0 minus tan t is what? Sine upon cos. You can put cos as your t. So cos's function, cos's derivative is available in the numerator. What it is? What it is? Minus of sine. Minus will be popped out. It will be what? It will stay out. So the derivative of this is what? ln of sec. You can put limit 0 to pi by 2 here. When you put pi by 2, what do you get? Sec 2 is what? 1 by, so sec 2 is what? Root 2. What it is? Root 2. And sec 0 is what? 1. That will be what? ln 1 is what? 0. Here, guys? Does anyone have any doubt? This is what? Pi by 4, and this is what? ln root 2, and we'll have 0. That's it. So this is the final answer. You can check it. If you feel like, you can cross check it. Let's move ahead. Yes, this is a good question. What it says? It says sine inverse sine x dx. Now just check this function. If you are planning to do like this, I'm writing minus pi by 2 to 2 pi x dx. Let me tell you guys, this can't be done. Now tell me why. There is a specific reason. Look at this. Sine inverse function's range is what? Its range is always minus pi by 2 to pi by 2. Can't go beyond that. Tell me one thing. So how can you write it like this, right? Because when you say x, that means it is having values till 2 pi, and that is not possible. So what can we do? Let's draw the function. Either draw the function. If you can't draw it, at least write the right values. So what I can do is, let's do this question first geometrically. Okay. So when you try this question geometrically, but before, again, if you want to draw the geometry also, you will have to go ahead with the first mathematical formulation only. So let's first formulate it. So now tell me, how will I formulate it? It's very easy. Wherever I see that it is going beyond, it is not being defined. What I mean to say is, see, sine x dx, and the last one is from 3 pi by 2 to 2 pi sine inverse sine of x dx. Now what I'll do is, I'll just place naught and I'll make sure that this angle, this x, because I'll be getting the output, this x, the inside this thing, this should always remains between minus pi by 2 to pi by 2. I have to do the formulation in such a manner. For this, it will cancel out, so I'll have what? Only x. So integration of x is what? X square by 2 minus pi by 2 to pi by 2 plus. Now for this, now pi by 2 to 3 pi by 2, what is the interval? This is the second quadrant and third quadrant. So in this quadrant, I have to make sure that my values remains where? Between minus pi by 2 to pi by 2. So let's do one thing. I can write this sine x as like this, because my overall output of the function, this should be between, right? So what I can do is, I can write sine as pi minus x, yes or no? Second quadrant, so sine is always positive, right? So when I'll be putting pi by 2, I'll get pi by 2, and 3 pi by 2, it will become negative, correct? So as you can see, I'm doing the formulation, and you can do the same formulation for the graph also. 3 pi by 2 to 2 pi, here what I'm doing is sine inverse. This is what? Fourth quadrant. So in fourth quadrant, I know sine is negative, right? What I can do is, I can write sine as x minus 2 pi. Because if you start from 3 pi by 2, you get what? Minus pi by 2, and that's what it is. Clear? Now, let's solve it. Now I can easily cancel out these things, and I'll change the color for you guys, because I think give you clarity when I'm cancelling it. So now put the values here. So obviously it's square positive, so the limit value will be at 0 here, plus pi minus x when I'll integrate it. So I'll have pi x minus again x square by 2, starting from pi by 2 to pi by 2, plus, and this is what? X square by 2 minus twice of pi x, 3 pi by 2 to 2 pi. Okay. Now the way I have done this, you can also do the graphical thing also. See, I said from minus pi by 2 to pi by 2, it is as it is. From pi by 2 to 3 pi by 2, I made it a line like this, pi minus x. So pi minus x, pi here, and with negative slope. Now from here, I made it like what? X minus 2 pi. Positive slope, but negative interval. Like, and this is the 2 pi. So if you want to calculate the area under this curve is, what it is, this is -1, this is again +1. So the area for this part will be 0 for sure. For this part also it will be sure, and we'll check it mathematically also. But finally this will be remaining, and this is a negative area. So what we'll do first, we'll calculate the area from mathematical method. Then after that we'll just use our geometry. What it is like a triangle. So what is the area of triangle is? Half base. Base is what? Pi by 2. And what is the height? Here height is what? Negative pi. What it is? Minus pi by 2. So looking at this, it says minus pi square by 8. Let's see whether we are getting the same answer from mathematical form or not. So when I put the limits, I get what? 3 pi square by 2 minus, it becomes 9 pi square by 4, 8. Then again minus, so pi square by 2 become plus, then I'll have pi square by 4 and 8. Okay. Plus, from here I have what? 4 pi square by 2 minus 4 pi square 9 pi square by 4 and 2, 8. We'll have plus, this will be what? 2 will cancel out, so I'll have what? By 3 pi square. Okay, now check. I have this pi square, it minus 9 pi square by 8. See, this is pi square by 2. This is 4 times pi square. Okay, so this is what? 2 times. So I'll have what? Positive 2 here. This is positive 3. So 3 only minus pi square, and this is pi square. So only positive pi square will be left over here. Positive pi square, positive pi square. This is pi square by 8, and this is minus 9 pi by square by 8. If you solve these two fractions, you'll get what? Minus 8 pi square by 8. So that is basically minus pi square. So that will also cancel out. So this pi square will cancel out with these two. Sorted. So how many terms are cancelled out? Only these are the leftover terms. This is pi square by 2, and this is 3 pi by square by 2. So if you cancel out, so this will give you only what? Only pi square. Now solve this. Pi square minus 9 pi square. So you get what? 8 pi square minus 9 pi square by 8. That is minus pi square by 8. See, we are getting the same answer what we got here. Everything is same. Copy. Right? As I told you in the beginning also, we will be getting the same answer. Okay? Give me a moment to quench my thirst. Let's move ahead. Let's solve more questions. Sin 100x cos 99x dx. Now tell me, how will you solve this question? Any idea? See, if you are planning to solve this question using your indefinite integration approach, that we have to substitute even power, and that means sin x as t. So let me tell you guys, I am not ready to expand it like this, because this will be what? 1 minus t raised to what? See, 1 minus cos raised to 98. So it will become like this. I am not ready to expand it with this. I can't. So let's check this way. Now let's talk about the properties. What are the properties we have? If I apply f of a plus b minus x, I'll get, this is sin x only, and this, because it's the fourth quadrant, and this will be negative, but it's an even power, same thing. For cos, it's fourth. So basically what I'm seeing is, my f of x is what? F of twice of pi minus x. Now when we have this, can you think about something? One property we spoke about, remember? 0 to a f of x dx plus integration 0 to a f of 2a minus x. Remember this property? This is the integration for 0 to 2a f of x dx. Remember it? And if this is the case, then it becomes what? Twice of 0 to a f of x dx. Do you guys remember it? So let's try this. when we use this property, so this integration, my value, this becomes what, twice of integration 0 to pi sine of 100x cos of 99x dx. Okay, now just see, if I apply again, if I do apply the same property, then the same property a plus b minus, if I apply a plus b minus x, I get negative thing from here, right? This is already positive, second this is negative, right? Let's apply this property. So 0 to pi sine of pi minus x, and this cos of 99 pi minus x dx. This is the second quadrant and this is odd power. So in second quadrant cos is negative, so negative power, so you have odd power. हेलो गाइस, वापस से मैं आ गया हूँ बिकॉज मुझे मालूम चला कि इसमें लैग आ रहा था. सो आई एम कनेक्टेड टू यू गाइस वंस अगेन. सो जस्ट लेट मी जस्ट चेक इट कि सब कुछ स्मूथ है. हाँ बिल्कुल सब कुछ स्मूथ आ रहा है अभी वापस से, सब कुछ स्मूथ है अभी. तो वापस से इस क्वेश्चन करते हैं. तो देखो इस क्वेश्चन में क्या बोल रहा था, आप लोग क्या बता रहा था इस क्वेश्चन के अंदर. इस क्वेश्चन के अंदर मैं आपको बोल रहा था कि अगर आप लोग पहले अगर इसका चेक करो, क्या f ऑफ ठीक है, तो एक 2a दिख रहा है ना, 2a टाइप का सा. तो अगर आप लोग चेक करते हैं f ऑफ x की वैल्यू, तो f ऑफ x की वैल्यू और f ऑफ 2a माइनस x की वैल्यू, तो 2a माइनस x क्या आ रहा है, वही का वही सेम चीज आ रही है. क्यों आ रही है, देखो बिकॉज क्या हो रहा है, ये क्या है, a जो है अपने यहाँ पर पाई है, फोर्थ क्वाड्रेंट है, फोर्थ क्वाड्रेंट में अपना साइन आता है नेगेटिव, लेकिन इवन पावर की वजह से वो तो हो रहा है सेम. कॉस आता है पॉजिटिव, तो वो हो रहा है एज इट इज, ऐसा का ऐसा. तो जब ऐसा हो तो हमारी वो जो प्रॉपर्टी थी, वो प्रॉपर्टी क्या बोलती है, वो प्रॉपर्टी क्या थी याद है, 0 to 2a f of x dx, that can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. And if this is equal, if f of x is equal to f of 2a minus x, तब इसको लिखते हैं हम लोग twice of 0 to a f of x dx. कब, when f of x is equal to what, f of 2a minus x. चलो पुट करते हैं उसे. जब पुट करोगे तो अब क्या हो गया, अब हो गया 0 to 2 pi. करता हूँ ऐसे, मैं डायरेक्टली इसको इंटीग्रेशन मान लेता हूँ. लेट्स से दिस इज i. नाउ माय i इज व्हाट, i इज ट्वाइस ऑफ 0 to pi sin of 100x cos of 99x dx. Okay, now let's do one thing, let's apply that property. What is the property, f of a plus b minus x integration a to b dx is equal to what, same limit a to b f of x dx, ये वाली प्रॉपर्टी. लेट्स अप्लाई इट. तो क्या आता है, देखो ये ट्वाइस ऑफ, ये क्या हुआ, आप देखो जैसे आपने इसको अप्लाई किया तो इंटीग्रेशन 0 to pi, ये अपना आया ऑलरेडी. साइन 100x क्या हो गया बेटा यहाँ पे, पाई माइनस एक्स, सेकेंड क्वाड्रेंट, तो साइन तो ऑलरेडी पॉजिटिव रहेगा ऐसा का ऐसा ही. लेकिन अपना कॉस जो है सेकंड क्वाड्रेंट में क्या होता है, नेगेटिव, और ऊपर से क्या है ऑड पावर. क्या रहेगा बेटा, ये माइनस बाहर आ गया ना. तो ये क्या हो गया, ये बिल्कुल कैसे दिख रहा है, दिस, लुक एट दिस, लुक एट दिस, ये कैसे दिख रहा है बेटा अभी. अगर आप इसे, मैंने देखो आई क्या माना है, आई अज्यूम दिस थिंग, तो माना ना पूरी की पूरी, इसको आई माना हुआ है, तो अपन ने आई माना है ना, तो ये क्या आ रहा है, माइनस ऑफ आई आ रहा है ना. तो ये क्या हो गया, ट्वाइस ऑफ आई इज इक्वल टू व्हाट, 0. आई क्या आ गया बेटा अपना 0. दैट्स इट, हो गया सवाल. क्लियर, आगे बढ़े. चलो अगला सवाल कर, अगले सवाल को देखो. अगले सवाल को अगर आप लोग देखते हो तो ये क्या आ रहा है, π/2 log sin x dx. अब बात आती है कि कैसे करें, क्या इसे स्टैंडर्ड फंक्शन में कन्वर्ट कर सकते हैं क्या, बताओ बताओ. नहीं कर सकते अभी तो स्टैंडर्ड में। तो क्या किया जाए, प्रॉपर्टी यूज किया है वो ए प्लस बी वाली, करते हैं चलो। 0 to π/2 log ऑफ cos x dx। अभी क्या समझ में आया, एक चीज, ये चीज समझ में आई कि अगर मैं ऐड कर दूं दोनों को, मान लो ये भी आया है, ऐड करूंगा तो फायदा क्या होगा, देखो log ऑफ sin x प्लस log ऑफ cos x होगा। sin x cos x मल्टीप्लाई में हो जाएंगे बिकॉज log है, तो उसको मैं sin 2x में कन्वर्ट कर सकता हूँ, तो ऐसी कुछ फॉर्म दिखेगी ना, है ना। चलो करके देखते हैं। i ये क्या होगा, ट्वाइस ऑफ i इज इक्वल टू व्हाट, 0 to π/2 log ऑफ sin x इंटू cos ऑफ x। अब देखो तो sin 2x में कन्वर्ट कर रहे हैं तो 2 से करो मल्टीप्लाई, 2 से करो डिवाइड, डन। चलो करते हैं। तो ये क्या हो गया, अब हो गया ये 0 to π/2 log ऑफ साइन ऑफ ट्वाइस ऑफ x, ये हो गया dx माइनस, अभी क्या हो गया 0 to π/2, ये क्या हो गया अपना log ऑफ 2 dx। क्लियर। चलो जब आगे बढ़ते हैं, ये तो इसका इंटीग्रेशन तो बहुत आसान है। अब बात आती है कि इसको क्या करें, 0 to π/2 log sin 2x, ये तो ऐसा तो आया लेकिन ये लिमिट का दिक्कत हो रही है ना। एक काम करें, प्रॉपर्टी लगाएं वापस से। कौन सी प्रॉपर्टी, वही जो भी पिछले क्वेश्चन में करी थी, कौन सी वाली, ये वाली 0 to 2a वाली लगाएं। चलो लगाते हैं, इसको ओपन करता हूं मैं। तो ये क्या आया, 0 to π/4 f of x बेटा क्या हुआ, f of x हुआ अपना वही log ऑफ साइन ऑफ प्राइस ऑफ x d of x प्लस अगेन 0 to π/4 log ऑफ 2a माइनस x। 2a क्या था अपना π/2, अगर साइन ऑफ 2 π/2 माइनस x है तो क्या होगा, सेकंड क्वाड्रेंट हुआ, सेम एज इट इज अपने पास वापस वही चीज आ गई, साइन ऑफ 2x dx। इसका इंटीग्रेशन क्या हुआ, log ऑफ 2 π/2। क्लियर। चलो जी अब आगे क्या करें, ये तो अपना चल ही रहा है, दिस इज इक्वल टू 2y इक्वल टू 2y। ये क्या हो गया अपना, ये ट्वाइस ऑफ इंटीग्रेशन 0 to π/2 हो गया, तो 0 to π/4 log ऑफ साइन ऑफ ट्वाइस ऑफ x dx माइनस π/2 log ऑफ 2। क्लियर। अब देखो बेटा, मेरे को इसको इसमें कन्वर्ट करना है, तो क्या कर सकता हूं मैं, तो ओनली थिंग आई कैन डू इज आई कैन सब्स्टिट्यूट 2x एज t। तो करते हैं, उसको करते हैं, तो ये क्या आया, ट्वाइस ऑफ dx इज इक्वल टू dt। और ऐसा करने से अपनी लिमिट भी सेट हो गई ना। देखो ट्वाइस ऑफ i, ये तो 0 हुई, ये हो गई क्या हुई π/2, तो ये क्या बन गया, log ऑफ साइन ऑफ 2x क्या हो गया t, 2 dx क्या हो गया dt। और वैसे भी डेफिनेट इंटीग्रेशन में लिमिट्स अगर सेम हो, फंक्शन से मतलब वेरिएबल से मतलब ही नहीं है वो, तो ऐसी ये अपनी प्रॉपर्टी नंबर हो गई 1। ये क्या हो गया बेटा, ये i नहीं हो गया एकदम बिल्कुल कॉपी, ठीक है ना, i तो अपने पास ये i है राइट हैंड साइड पे, i ये 2i कैंसिल आउट हुआ, तो अपने बचा क्या, i इज इक्वल टू माइनस π/2 log ऑफ 2, दैट्स इट, ये बचा अपने पास। क्लियर। डाउट नहीं ना। चलो अब आगे बढ़ते हैं, अगला क्वेश्चन करते हैं। ओहो यहां तो है कॉन्सेप्ट। अब आता है डेरिवेटिव ऑफ डेफिनेट इंटीग्रेशन। तो डेरिवेटिव निकालना, क्या डेफिनेट इंटीग्रेशन आप कहोगे सर डेफिनेट इंटीग्रेशन है तो डेरिवेटिव क्या मतलब, बिल्कुल सही कह रहे हो कि आपका जो मतलब है कि अगर आप सोच रहे हो कि अगर अपने को कांस्टेंट लिमिट्स दे रखी है, अपर लिमिट और लोअर लिमिट क्या है कांस्टेंट, तो ऑब्वियसली एक फिक्स्ड वैल्यू आती है, तो फिक्स्ड वैल्यू का डेफिनेट फिक्स्ड वैल्यू का डेरिवेटिव तो 0 आएगा, ऑब्वियसली 0 आएगा। तो डेरिवेटिव तो 0 आएगा, इसीलिए that's why what happens is in this in this question, what do they do is they actually make sure either of the limits or both the limits, either of the limits and both the limits is what? They are function of x. So what say? So they write it like this. I'm taking the very generalized example. So now, what is the answer we get? But before that, I'll tell you one thing. So if we know that nt derivative of f of x is capital F of x, then see, this answer is what? F of hx. This is the final answer we get when we integrate it. Now you want to differentiate this. Fine, differentiate this. When you differentiate it, put dy dx here, put dy dx here. Differentiate. Now how will you differentiate it? So you would find that it was antiderivative. So when you're differentiating it, it will first convert into the function like this. Now you can apply the chain rule, so it will become h dash x. Similarly, f of g of x and g dash x. And what it is called? This is called your Leibniz rule. Leibniz rule. Okay, so remember this. That's how we find the derivative of definite integration. Cool. Let's move ahead. Let's solve the question. The question is variable x and y are related by equation x is equal to integration 0 to y dt root 1 plus t square. Then we have to find the value of double derivative of y. Okay. So as the question clearly says, we have to find what? Derivative. So what do we need to do? Focus on this thing. Differentiate the equation itself. Let's differentiate. So derivative of x is what? 1. 1 is equal to. Now we have to put the value here, upper limits in the function itself. 1 plus y square. Let's differentiate y, dy by dx. What is your dy by dx? Now root of 1 plus y square. Now the task is we have to find the double derivative. Let's differentiate it again. So what will be the differentiation of this? Half. Then root of 1 plus y square. Then derivative of this 2y. Then dy by dx. Correct? Now 2 will cancel out. What is dy by dx? That is root 1 plus y square. That means this denominator and this numerator will cancel out. What is left now? d2y upon dx square is what? Only y. This is left. What is the correct option? Do we have? Yes, we have B option. B is the correct answer. Here, Akhilesh, Rachli, right? Let's move to our next question then. And this is the last question of the day. The question is, let f is what? R to R is a differentiable function. And f of 1 value is what? 4. It is given to us. Then we have to find the value of limit x tending to 1, limit 4 to f of x, 2t dt upon x by 1. Now when you read this question, the very first thing what you see is it is given differentiable. That means someone is asking you to differentiate also, or you can differentiate also. And the thing is that the variable here is what? T. With respect to t, we are integrating. So that means x minus 1 is what? It will work like a constant. So if it is going to work like a constant, let's put it out. We pulled it out. So 4 to f of x. What is the integration of 2t dt? T square, right? So let's write the integration here. So t square and 1 upon x minus 1. I'm putting the limits also. F of x square minus 4t 4 square. Now let's put the limit. When you put the limit, f of x is f of 1 is what? It is given to 4. So 16 minus 16 0. 1 minus 1 0. So 0 by 0. That is indeterminate form, right? What to do now? Now, since it is about the derivation, and look at the options also, there is f dash. That means we can clearly use L'Hopital rule. Let's use L'Hopital rule. This is limit x tends to 1. If I use L'Hopital in the numerator, so twice of f of x, f dash x upon 1. Here, now apply the limit. It will become what? Twice of f of 1 into f dash 1. Okay. Now, what is f of 1? It is 4. So, 8 times f dash 1. Which option do we have? Yes, we have D option. That's it. Easy question, right? Okay. So, this was our long marathon session which finally ended. And I hope you guys have learned. You guys must have revised whatever your remaining concepts we started with, theory, everything. And I request you guys to solve questions if possible today and maybe tomorrow. Then once you're done with it, then we'll be starting tomorrow around 8 o'clock. We'll start again a new session. That will be again a marathon session on application of derivative. We'll solve multiple questions, so just be ready with that. And I would like to inform you regarding my fun day series. So I conduct a fun day series where on Unacademy application. Okay. The main objective of this fun day series is to learn fundamentals using the questions. Unacademy application. So if you want to attend it, what you need to do is first install Unacademy application. Once you install Unacademy application, then what are you going to do? Then follow me first. Follow me on Unacademy application again. Once you do that, then you'll get the notification of all the fun days, all the special free live classes. What I conduct? Free special classes. So anyone can come and attend those classes and come and see the difference. What class you attend here on YouTube and the kind of platform we have on Unacademy. You will enjoy. This is remarkable experience. Okay, so come there. And I would like to inform you guys that tomorrow at 10 a.m. I am going to conduct a quiz. Quiz on what? Indefinite integration. Yes, indefinite integration. So you guys can come and attend the quiz. Okay. Next is I would like to thank you Cengage book because I took many of Cengage book's question. So thanks a lot Cengage book. And our daily ritual. If you have liked my video, if you like the marathon session, I would request you to like it and share it with your friends. And subscribe this Let's Crack JEE channel so that you can watch every single video and you'll get the notification also whenever any video comes. And if you hit the bell icon button, this will help you out to get notified whenever I come online. Okay. And people, those who have decided that they'll be buying Plus or Iconic subscription, do use my code NK001. You will be saving 10% for sure. That's a gift from my end. Okay. And if you want more update about this channel, please join this Telegram group whose link is given in the description. You can join it. Okay guys. So I hope you guys have enjoyed the session. So we'll take your leave, and tomorrow again at 8 a.m. you guys can come and attend the session. And people, those who are those who find difficulty with English language and they want to attend the same sort of session, they can come to JEE Quest channel. Where? JEE Quest channel. Come there. I deliver lecture there in Hindi, so you can come and attend the lectures. Bye guys, take care. It was nice teaching you guys. I really enjoyed it. I hope you also find this session useful for you. Good night. Bye bye.